Hello everyone, in this lecture I will solve different problems in the laws of motion. So let's start. If m equal to 6 kilograms, what is the tension in string 1? Now in this situation here, we have actually two systems, the mass here and we have the weight is directed this way. Here it's mg and we have tension, it's T. Now we have also tension on this one and let's name it B, and tension on this one and let's name it A. Now to solve this one here, let's create a simple table like this one, x components and y components for this one here, and A as a vector. This one here, it has minus A sine 30 because this is 30 here. Now the one with the angle take the cosine, and this one here A sine 30 with minus sine, and again this one here take the cosine, and this one here B sine 60. Now the x component for B is actually equal to B sine 60 is 60. Now the y component for A is A cosine 30, and the y component for B is equal to B cosine 60. Now for this system here, sum of all forces on y equal to 0, so mg minus tension equal to 0, so tension T is actually equal to mg. Now to find T1 and T2, sum of all forces on y for the other system, it's equal to 0, so in this case A cosine 30, this one here, plus B cosine 60 is actually equal to tension right here, or G, and in this case the other equation we can get it from the x components, sum of all forces on x is equal to 0, or in other words A sine 30 minus sine plus B sine 60 equal to 0, and from this one here A equal to B sine 60 over sine 30. You substitute this A, this one here, back in this one, you will get from this one here B sine 60 over sine 30 times cosine 30 plus B cosine 30 equal to mg. You simplify this one here, you will find B times 1.49 plus 0.5 is equal to 60, or B in this case equal to 30.15 newtons. You substitute B back in this one here, you will find A equal to 52.1 newtons. An object of unknown weight is suspended as shown in this one here. We don't know the weight for this object. The tension in rope 1 is 25 pounds. So this one here, let's name it T, equal to 25 pounds. And the tension in rope 2 is 31 pounds. And this one here, T2 equal to 31. And this T1 equal to 25 pounds. What is the weight of the object? Now, let's follow the same procedure as the previous example, but this one here, the angle, it's with the x-axis. In this case here, now sum of all forces equal to 0, and for this one here, we have weight, tension. So mg minus tension equal to 0. In other words, mg equal to tension T. Now let's find tension T here. Now again, x components, since we have more than one vector, and this is y components, and let's analyze them. The first one, it's minus a, the x component, minus a cosine 37. By the way, this is a and this is b. And a sine 37. And this one, b cosine theta. And this one here is b sine theta. And sum of all forces on y, again, equal to 0 on y. This is y here, which means this one, a sine 37 plus b sine theta minus mg equal to 0, and sum of all forces on x equal to 0 as well. In this case, sum of all forces on x equal to 0, or we can find that a cosine 37 equal to b cosine theta. And you simplify this one here, you will find that cosine theta is actually equal to 25 divided by 31 cosine 37, and theta will be equal to 50.2 degrees. Now you substitute this theta in this equation here, you will find mg equal to 25 sine 37 plus 31 sine 50.2, and you simplify this one here, you will find mg equal to 39 pounds. If alpha equal to 40 degrees and the tension and strength 2 is 30 newtons, how much m? If we look at this figure here, we will see that it's a symmetric situation, this one here. So if you solve one of them, there's no need to solve the other part. So let's solve this part right in here, this one here. Now let's find the forces on the system. We have here mg, and we have here tension, and this T2, and this one here, it's T1, and the angle here is equal to alpha. So sum of all forces equal to 0 on y in this one here. So tension minus mg equal to 0. So tension equal to mg. Now let's analyze T1 and T2. In this case, let's find the x components and the y components. And again, this is the easiest way to simplify the vectors here by analyzing them into their original components. T1 in this case minus T1, the x component, cosine alpha. So if this is alpha, and remember we analyze the vector with its tail, not with its head. So this is alpha, so this will be alpha here. So the x component, it's T1 cosine alpha, and the y component, T1 sine alpha. Now for T2, there's only x component for this one here. It's T2, just T2, no y component whatsoever. Now sum of all forces on x equal to 0, and from this one here, T2, this one, minus T1 cosine alpha equal to 0, alpha equal to 40, and T2 equal to 30. And from this one here, you will find that T1, it's equal to 30 divided by cosine 40, or in other words, it's 39 newtons. Now, sum of all forces on y equal to 0. This is y, this one here. So T1 sine alpha minus T, we just calculated T, this one T here, equal to 0. And from this one here, T1 sine alpha equal to mg. And you simplify this one here, you will find that m here equal to 2.5 kilograms. Two forces are the only forces acting on a 3 kilogram object which moves with an acceleration 3 meters per second square in the positive y direction. If one of the forces acts on the positive x direction and has a magnitude 8 newtons, what is the magnitude of the other force? Now we have here in this situation an object with 3 kilograms and the acceleration 3 meters per second square in the positive y direction. Now one of the forces, it's in the positive x-axis with magnitude equal to 8 newton. We would like to calculate the magnitude of the other force. Now let's have a quick sketch here. We have two forces, one of them on the x direction, let's name it F1 with magnitude 8 newtons. The other one, we don't know in what direction or the magnitude, and let's name it F2, making some angle theta. Again, it's unknown angle for this one here. Now sum of all forces on x is equal to 0 because there's no acceleration in the x direction. And again, in the x direction we have F1 plus the other force is F2 cosine theta equal to 0. And from this one here, F1 is equal to minus F2 cosine theta. Now sum of all forces on y is equal to, in this case it's not 0, it's equal to MAY because it's given in the question, it's 3 meters per second square in the positive y direction. So in this case here, F2 sine theta, no x component for the F1, equal to MA. And by simplifying this one here, 8 equal to minus F2 cosine theta and MA equal to F2 sine theta. If we divide these two equations, you will get tan theta equal to minus MA over 8, and in this case here, tan theta equal to minus 9 over 8, and theta will be equal to minus 48 degrees. You substitute this theta in one of these two equations, you will find that F2 equal to 9 divided by sine minus 48, or in other words, F2 equal to minus 12.16 newtons. The horizontal surface on which the block slides is frictionless. If F equal to 20 newtons, M equal to 5 kilograms, what is the magnitude of the resulting acceleration of the block? So we'd like to calculate the magnitude of the resulting acceleration of the block if we know F here equal to 20 newtons and M here equal to 5 kilograms, assuming that there is no friction whatsoever. In this case here, sum of all forces on y equal to 0 and sum of all forces on x equal to MAX. And let's analyze forces on x. We have here F and we have F Remember, we're taking the angle with the tail, not with the head. So this is theta, which is 30 in this case. F cosine 30 plus F, it's equal to A. F in this case, 1 plus cosine 30 equal to MA. So A in this case, the acceleration, it's equal to 20. The force F is 20 times 1 plus cosine 30, all divided by 5. In other words, the acceleration will be 7.46 meter per second square. The only two forces acting on a body have magnitudes of 20 newtons and 35 newtons and directions that differ by 80 degrees. The resulting acceleration has a magnitude of 20 meter per second square. What is the mass of the body? Now we have here actually two forces, F1 and F2. This one F2, and the angle between them, it's 80 degrees. Now to deal with this situation, let's rotate the coordinates. This is x and y, this right here. Let's rotate the coordinates in such a way F1 matches exactly with the x-axis, and this is y-axis. So this will be x-axis, and this will be y-axis. In this case here, we have two forces, one of them on the x-axis, the other force in the xy axis, making 80 degrees with the positive x-axis. So sum of all forces on x equal to A. Again, F1 plus F2 cosine theta equal to, the acceleration is 20 and the mass equal to just m. You simplify this one here, the mass of the object, it's equal to 20 plus 35 cosine 80 divided by 20, and m in this case, it's 1.3 kilograms. If the only forces acting on 2 kilogram mass are F1 equal to 3I minus 8J newtons and F2 5I plus 3J newtons, what is the magnitude of the acceleration of the particle? As we can see here, we have two components for F1 and two components for F2. In this case here, sum of all forces on X equal to AX, and let's see sum of all forces on X. This one is 3 and this one is 5. So sum of all forces on X is actually equal to 3 plus 5 equal to, the mass of the object is 2 kilograms to AX, and you will find from this one here AX is equal to 4 meter per second square. Now sum of all forces on Y equal to MAY. Let's see here. The Y component for F1, it's minus 8, and the Y component for F2, it's 3. So minus 8 plus 3 equal to 2, the mass of the object, AY. You simplify this one here, AY will be equal to minus 2.5 meter per second square. Since the question asks for the magnitude of the acceleration, now in this case, A here equal to square root of AX square plus AY square. And AX in this case, it's 4, and AY in this case, it's minus 2.5. So the magnitude of A is equal to 4.7 meter per second square. At an instant when 4 kilogram object has an acceleration equal to 5I plus 3j meter per second square, one of the two forces acting on the object is known to be 12I plus 22j in newtons. How much? The magnitude of the other force acting on the object. Now in this case here, one of the forces we have, it has two components, one on x and one on y, and we actually having two acceleration, one on x and one on y. The mass of the object is 4. We need to calculate the magnitude of the other force. Now to solve this one here, sum of all forces on x equal to max in this case. Now on x we have 12 from F1 plus F2x, that's what we looking for, equal to the mass 4 and the acceleration on x, it's 5. Other words, F2x is equal to 8 newtons. Now sum of all forces on y equal to may. In other words, F1 on y, it's equal to 22 plus F2 y that we are looking for equal to 4 times 3. This one here, the ay acceleration times 3. So F2y equal to minus 10 newtons. So F2 as a vector is actually equal to 8I minus 10j hat. And the magnitude for F2 is equal to square root of 8 square 64 plus 10 square 100, or square root of 164, or equal to 12.8 newtons. If F equal to 4 newtons and M equal to 2 kilograms, what is the magnitude A of the acceleration for the block shown below? The surface is frictionless. Now let's see the situation here. We have an acceleration here and we have F, and this F making 40 degrees. The surface is frictionless. Now sum of all forces on X equal to MAX, and in this case here we have F plus X component for this F here, F cosine 40 equal to MA. You substitute numbers, F equal to 4 plus 4 cosine 40 equal to 2AX, and you simplify this one here, you will find A equal to 3.5 meter per second square, and it's in the positive X axis. A block is pushed up a frictionless 30 degrees incline by an applied force as shown. If F equal to 25 newtons and M equal to 3 kilograms, what is the magnitude of the resulting acceleration of the block? Now to solve this situation here, let's draw the free body diagram. Remember, the weight is directed to the center of the earth. This is mg, this one here, and we need to analyze the weight. So we'll have mg cosine theta and mg sine theta. Now since F directed this way here and the angle with the head, now we need to calculate or to find the angle with the tail of the vector, which is, this has to be 30 degrees. So this one here, the x component it's F cosine theta directed this way. Now, sum of all forces on X equal to, this is X by the way, this is X and this is Y. On X we have mg sine theta and we have F cosine theta. Since the object is moving upward because it's pushed up, in this case, sum of all forces on X equal to ma. Now, F cosine theta minus mg sine theta equal to ma. Now, you substitute numbers, 25 cosine 30 minus 30 sine 30 equal to 3a, and a in this case it's 21.65 minus 15 divided by 3, and the acceleration a, upon simplifying this one here, it's equal to 2.2 meter per second square. A 5-kilogram object is suspended by a string from the ceiling of an elevator that is accelerating downward at a rate of 2.6 meters per second square. What is the tension in the string? Now let's draw the situation. Here's the elevator right here, and an object is hanged by a rope like this. Now let's draw the free body diagram. This is mg and this is the tension, and the elevator is moving downward, so the acceleration will be this way, like here. So sum of all forces on y equal to ma, and in this case here mg minus tension equal to ma. Remember, the one with the acceleration, you start with it. So mg minus tension, it's equal to ma, and tension in this case, it's equal to mg minus ma, or m times g minus a. You substitute numbers, you'll find that T equal to 5 times 10 minus 2.6. In other words, tension equal to 37 newtons. The tension in a string from which a 4-kilogram object is suspended in an elevator is equal to 44 newtons. What is the acceleration of the elevator? Now in this case here, sum of all forces on y equal to ma, and in this case here, tension minus mg equal to ma, or 44 minus 4 times g, in this case it's 10, equal to 4a. You simplify this one here, you will find a equal to 1 meter per second square. Since acceleration is positive, it means it's moving upward. A 5-kilogram mass is attached to the ceiling of an elevator by a rope whose mass is negligible. What force does the mass exert on the rope when the elevator has an acceleration 4 meters per second square upward? Now again, we have this is the elevator box, and we have an object hanged by a rope like this. So sum of all forces on y equal to ma, tension minus mg equal to ma. Actually, we start with tension because the acceleration is upward. The one with the acceleration, you start with it. So tension minus mg, it's equal to ma, and tension in this case, it's equal to 5 times 4 plus 10, and in this case it's 70 newtons. A 2-kilogram block slides on a frictionless 25 degrees inclined plane, a force of 4.6 newtons acting parallel to the incline and up. The incline is applied to the block. What is the acceleration of the block? Now let's have quick sketch here. So here's the situation, and we have inclined plane, and this one here equal to 25 degrees, and we have a block, this one here, and the force is pushing this one like this. Now we would like to calculate the acceleration of the block. Now sum of all forces equal to A. Now let's see the forces acting on this one here. The weight is directed this way here, and we have mg cosine and mg sine theta. Since the object is sliding on a frictionless surface, in this case here, mg sine theta minus f equal to A, or 20 sine 25, 20 because the mass is equal to 2 and g equal to 10, minus 4.6 divided by the mass equal to 2. This is equal to actually A, and A in this case equal to 1.9 meter per second square. A 1.5 kilogram object has a velocity of 5j meter per second at t equal to 0. It's accelerated at a constant rate for 5 seconds, after which it has a velocity of 6i plus 12j meter per second. What is the magnitude of the resultant force acting on the object during this time interval? So what we're looking for here is the magnitude of the resultant force. If we have the initial velocity here equal to 5j hat, and it's accelerating for 5 seconds, the time is given here, and the final velocity is this one right here. So let's just write the given information. V initial equal to 5j hat, and V final equal to 6i plus 12j hat, and time interval equal to 5 seconds. V final x, use the equations of motion, equal to V initial x plus axt. We would like to calculate actually ax and ay. Once we calculated ax and ay, we can calculate the force using Newton's second law. So let's calculate here ax. Now V final x equal to V initial x plus axt. No initial x, it's 0 in this case here, and ax equal to 6 minus 0 divided by 5, or 6 over 5 meter per second square. Now V final y equal to V initial y plus ay t. Again, ay equal to 12 minus 5, this 5 here, divided by 5, because the initial y equal to 5j hat, which equal to 7 over 5 meter per second square. Now sum of all forces on x equal to max, and fx in this case equal to 1.5 times 6 over 5, or 1.8 newtons, and sum of all forces on y equal to may, or fy equal to 1.5 times 7 over 5, or 2.1 newtons. F as a vector equal to fx I plus Fy j, or F equal to 1.8 I hat plus 2.1 j hat. The magnitude for F, it's equal to square root of Fx square plus Fy square. You calculate this one here, you will find the magnitude for F equal to 2.8 newtons. A 2 kilogram object has a velocity of 4I meter per second at t equals 0. A constant resultant force of 2I plus 4j newtons then acts on the object for 3 seconds. What is the magnitude of the object velocity at the end of 3-second intervals? Now in this case here, we have initial velocity, this one right here, and we have a force acting on this object and it's constant, and we have x component and y component for the force. The time interval equal to 3 seconds, and we would like to calculate the velocity at the end of the 3-second time intervals. Again, to calculate the velocity, we need to calculate the acceleration. Once we calculate the ax and ay, we can use equations of motion and find the velocity components. So sum of all forces on x equal to m ax, and in this case here 2 equal to 2ax, 2fx, this one here is 2, and the mass equal to 2, ax equal to, in this case, 1 meter per second square, and Fy equal to may. In other words, Fy equal to 4 equal to 2ay, and ay in this case equal to 2 meter per second square. Now we calculated ax and ay. We can find the final velocities x and y using equations of motion. A final x, the initial x plus axt, and the final x equal to, now v initial x, it's 4I hat, so it's 4 plus ax is just 1 times t, it's 3, and in total the final x equal to 7 meter per second. Now the final y, same rule, the initial y plus ayt, and the final y equal to the initial velocity on the y component equal to 0 plus the acceleration on y, it's 2 times 3, or the final y equal to 6 meter per second. So v in this case as a vector equal to 7I plus 6j, and the magnitude for v equal to square root of 7 square plus 6 square, or it's equal to 9.2 meter per second. Only two forces act on 3 kilogram mass. One of the forces is 9 newtons and going to the east, and the other one is 8 newtons in the direction of 62 north of west. What is the magnitude of the acceleration of the mass? Now to solve this one here, let's just have a quick sketch. Here we have a force directed to the east with magnitude equal to 9 newtons, assuming that this is the east and this is the north, this is the west, and this is the south. Now the other force, it's 8 newtons in the direction of 62 north of west. You actually in the west and going to the north with 62 degrees. This is the meaning of north of west, 62 degrees this way right here, and equal to This is F2 equal to 8 newtons, and this is F1. Now, what is the magnitude of the acceleration? We need to calculate the magnitude for the acceleration. In this case here, sum of all forces on x equal to max. Now on x we have 9, this one directed this way here, 9, and the other one it's 8 cosine 62 and going to the left. So in this case it's equal to 9 minus 8 cosine 62. This equal to the mass equal to 3ax. And from this one here, ax equal to 1.74 meter per second square. Now sum of all forces on y equal to may, and in this case here, let's see, on y there is no F1 component, so the only component we have here, it's F2, which is 8 sine 62, so 8 sine 62, no F1 components, equal to 3ay. You simplify this one here, you will find ay equal to 2.35 meter per second square. So a in this case as a vector equal to 1.74 I plus 2.35 j, and the magnitude for a, it's equal to square root of ax square ay square, or in other words 2.92 meter per second square. You have a machine which can accelerate bugs on frictionless ice. Starting from rest, the bug travels a distance x in time t when force F is applied. If force becomes 3F, the distance the bug travels in time will be, we have a bug and the force applied on that bug equal to F, and the bug travels a distance x in time interval t. Now if the force is tripled, how much the distance will be? Now to solve this one here, sum of all forces, again Newton's second law, equal to ma, or in this case a equal to F over m. Now x, I'm talking about the first situation here, x in this case it's equal to xi plus the initial xt plus half a t square, starting from rest and origin. So x in this case equal to half a t square, so x equal to half and a equal to F over m t square. So this is the situation before tripling the force F. Now after the force is tripled, let's see situation number 2, the sum of all forces equal to ma, and in this case a equal to 3F over m. Now x here, no need to repeat things here, x equal to half a t square, or in other words x equal to half 3F over m t square, or you can write like this, 3 times half F over m t square, and this is actually the distance before the force tripled, so the final distance equal to 3 times the initial distance. The horizontal surface on which the objects slide is frictionless. If m equal to 2 kilograms, the tension in string 1 is equal to 12. How much F? Now in this case, here sum of all forces equal to MA, and in this case here all forces is F applied on this system here. This whole thing here is just F equal to the mass is the total mass M plus 2M plus 2M or 5M A, and in this case here A equal to F over 5M. Let's keep this one here. On 2M here, F minus tension, it's equal to 2MA. Now sum of all forces on system 2 equal to 2MA, and in this one here, F minus tension equal to 2M, and A we just calculated this from here, times F over 5M, and you simplify this one here, F minus 12, because the tension it's a 12, equal 2F over 5, or in other words, F equal to 20 newtons. The surface of the inclined plane shown is frictionless. If F equal to 30 newtons, what is the magnitude of the force exerted on 3 kilogram block by the 2 kilogram block? Now let's have free body diagram here. This is mg right here, and this one here mg sine theta. Again, this is m2g is 1m1, and this m2g sine theta, and this one cosine, and this one cosine, m2g cosine theta, m2g cosine theta. Now sum of all forces equal to MA F minus mg sine theta equal to MA. I'm talking about here the whole system here with mass equal to 2 plus 3 kilograms. It's 5 kilograms. So in this case here, A equal to 30 minus 25 divided by 5, or equal to 1 meter per second square. So this is the acceleration for the whole system. We actually looking for the force exerted on the 3 kilogram object by the 2. In this case here, F minus mg sine theta plus F2 on 3 equal to 2a. Now this one here, let's see. F minus mg sine plus F2 on 3, this force here, equal to 2a. In other words, F2 on 3 equal to 2 times 1, the acceleration is 1, plus 10, because the mass equal to 2, and g equal to 10, sine theta is equal to half, so it's just 10 minus 30 newtons is the magnitude for F. So in total, it's equal to 18 newtons. If P equal to 6 newtons, what is the magnitude of the force exerted on block 1 by block 2? Now in this case here, we are looking for the magnitude of the force exerted on block 1 by 2, this one right here. P equal to MA. So the total force is P in this case. Let's calculate the acceleration for the whole system. So 6 equal to the total mass equal to 5 plus 3 plus 2, it's equal to 10, like this, and A, and in this case here, A equal to 0.6 meter per second square. Now, the force exerted on block 1 by block 2, now let's find this one here. We have P minus this force F2 on 1, P minus F2 on 1 equal to 2A. So F2 on 1 equal to 6 minus 12 over 10. Or in other words, F2 on 1 equal to 4.8 newtons. If F equal to 40 newtons and M equal to 1.5 kilogram, what is the tension in the string connecting M and to M, assuming that all surfaces are frictionless? Now, in this situation here, the system is moving with acceleration in this direction. It's A. Now, we have here the free body diagram. We have here mg, and we have tension. We have also tension in this one here. Now, sum of all forces equal to MA, or tension minus mg equal to MA. Again, the one with the acceleration, we start with it. So tension minus mg equal to MA, and F minus tension equal to 2MA. Now, from the system 1 here, tension minus mg equal to MA, and from system 2, this is system 2 here, it's force minus tension is equal to 2MA. When we add these two equations, you will get F minus mg equal to 3MA, 40 minus 15 equal to 4.5 A, and after all, A equal to 25 divided by 4.5, and A will be equal to 56 meter per second square. Now, to calculate the tension, you substitute this acceleration in one of these two equations. You will find tension equal to MA plus mg, or M times A plus G. Tension equal to 15 times 15.6 plus 10, or equal to 23.4 newtons. If M equal to 2.2 kilograms, what is the tension in the connecting string? The poly and all surfaces are frictionless. Now, here's the situation. We would like to calculate the tension in this one here. Now, we have, this is system 1 and the free body diagram for this one here, mg, and we have here tension. Now, we have here the weight, and when we analyze the weight, it will be mg sine theta and mg cosine theta, and the tension here is directed this way here. Now, let's name it 1 and 2. On 1, sum of all forces on 1 equal to MA. Since the object is moving downward this way here, the acceleration, so mg minus tension equal to MA, and on system 2, this one here, the tension and mg sine theta both in the same direction, so tension plus mg sine theta equal to MA. You add these two equations, you will get mg plus mg sine theta equal to 2m a, and mass with mass with mass, you will find a equal to 10 times 1.5. You just substitute numbers divided by 2, and in this case a equal to 7.5 meter per second square. Now this is the acceleration for this one here. Now let's substitute this acceleration back in one of these two equations. You will get mg minus tension equal to ma, and tension in this case equal to mg minus ma. You substitute the numbers, you will get 22 minus 16.5, or tension in this case equal to 5.5 newtons. A 4 kilogram block slides down a 35 incline at a constant speed when a 16 Newton force is applied acting up and parallel to the incline. What is the coefficient of kinetic friction between the block and the surface of the incline? Now, to solve this situation, let's just have a quick sketch here. Here the surface, and we have here an object, force F directed this way, and this is the weight for object, and this is mg sine theta. The angle here is 35 degrees. Now we would like to calculate here the coefficient of kinetic friction between the block and the surface. Since the object is sliding down this way here with constant speed, it means the acceleration equal to 0. We will get mg sine theta minus f minus fk equal to 0, again because the system is moving with constant speed. So fk here equal to mg sine theta minus f, or 40 sine 35 minus 16, in this case fk equal to 6.94 newtons. And remember, fk here, it's equal to mu k n. Now to find the normal, let's use sum of all forces on y equal to 0, and in this case here the normal minus mg cosine theta. This is the normal and this is the mg cosine theta equal to 0. So the normal for this one here, it's equal to mg cosine theta. So mu k, or the coefficient of kinetic friction, equal to fk divided by mg cosine theta, or you substitute numbers, you will get mu k equal to 0.21, and remember it's dimensionless. In a game of shuffleboard played on a horizontal surface, a buck is given an initial speed 6 meters per second. It slides a distance 9 meters before coming to rest. What is the coefficient of kinetic friction between the buck and the surface? Now the buck is moving 9 meters before coming to rest, so the final velocity of the buck is equal to 0 and the initial velocity equal to 6. Now we would like to calculate the coefficient of kinetic friction between the buck and the surface. Here's the situation. The buck, this one here, is pushed with initial velocity 6 meters per second, and the final velocity, it's coming to rest, 0, and the total distance here, it's 9 meters. And from this information here, let's calculate the acceleration. So the final square equal to the initial square plus 2a delta x, and 0, it's coming to rest, equal to 36 6 square plus 2a, and delta x, it's just 9. And from this one here, a equal to minus 2 meter per second square, the negative sign because it's the accelerating, which makes sense. Now we would like to calculate the coefficient of kinetic friction, sum of all forces equal to ma, and the net force on the back is equal to 0 minus Fk equal to ma. Now in this case here, minus mu k n equal to ma, and sum of all forces on y equal to 0, and normal equal to mg. In other words, mu k minus mg equal to ma. Mass with mass, you substitute a, it's minus 2, and in this case minus mu k times 10 equal to minus 2. In other words, mu k equal to 0.2. A 2 kilogram block slides on a rough horizontal surface. A force with magnitude 4 newtons acting parallel to the surface is applied to the block. The magnitude of the block acceleration is 1.2 meter per second square. If P is increased to 5 newtons, determine the magnitude of the block acceleration. Now here's the situation. We have a block here and a force, horizontal force P equal to 4 newtons, acceleration equal to 1.2 meter per second square. We would like to calculate the magnitude of the block acceleration if the force P is increased to 5 newtons rather than 4 newtons. Now let's solve it for 4 newtons. Sum of all forces equal to ma, and F minus Fk equal to ma, and 4 minus mu k, normal in this case it's equal to mg, equal to ma. Now you just simplify this equation. 4 minus ma divided by mg, this is mu k, and you substitute numbers. Mu k in this case equal to 0.08. Now sum of all forces is equal to ma, and in this case it's 5 minus 0.08 times 20 equal to 2a. You simplify this one here, you will find a equal to 1.7 meter per second square. The idea of this question, by the way, we just calculated the mu k, we substituted back in the other part. In the figure shown, the coefficient of kinetic friction between the block and the incline is 0.29. What is the magnitude of the acceleration of this suspended block as it falls? Disregard any pulley mass or friction in the pulley. Now, again, we have tension in this one here. Mg sine theta is mg cosine theta. We have friction in this case here. Now, sum of all forces on system 1, this one, we have mg, we have tension. And the system is sliding, so it's going downward here. On system 1, sum of all forces equal to ma, or in other words, mg minus tension equal to ma. On system 2, tension plus 2mg, because the mass is 2m, sine theta minus friction, kinetic friction, equal to 2ma. You add these two equations, you will get mg plus 2mg sine theta minus fk equal to 3ma, and fk here equal to mu k n. To find n, let's have sum of all forces on y equal to 0, and in this case here, normal minus 2mg cosine theta equal to 0, so the normal equal to 2mg cosine theta. You substitute this normal back in this force here, you will get mg plus 2mg sine theta minus mu k 2mg cosine theta equal to 3ma. Mass with mass with mass with mass, and in this case here, a equal to 10 plus 10 minus 0.29, it's mu k, times 2g, it's a 20, times 0.87, it's cosine 30, divided by 3, and a in this case, it's equal to 4.98 meter per second square. 3 boxes slide on a frictionless horizontal surface when pulled by a force of magnitude F. When we compare the tension T1 and T2 with the force F, we find that. Now in this question, we would like to compare T1 and T2 with respect to the force F. Let's see, F, this one here, minus T1 equal to ma, and T1 minus T2, it's equal to ma, and T2 equal to ma. And remember, is 1, 2, 3. And remember, sum of all forces, or the net force, it's equal to ma. And in this case here, a, the acceleration, equal to the net force, it's actually F. F divided by the total mass, it's 3m. You substitute this back in this one here, you will find T1, actually, it's equal to F over 3 plus F over 3, or it's equal to 2F over 3. And T1 minus T2 equal to mF over 3m, mass with mass here. T2, it's equal to F over 3. So if we just rearrange them, T1 equal to 2 over 3 F, T2 equal to F over 3. So when we compare them, F is actually greater than T1, which is greater than T2. That's it. Thank you for watching.